Okay, most of this that we're going to go through is pretty easy, the application. It's kind of hard to understand how we got the formula, but this formula right here isn't too bad. Where A is your starting amount, that's your first term, right? Before anything happens. R is your common ratio. Common ratio. All right. And N is just the number of terms. And just remember, if you want to find a ratio, you take any term and divide by the term in front of it. Let's use that. Ready? We're going to come down here, we're going to find a ratio. We're going to take any term, I don't know, let's start with an easy one, 15, and divide by the term in front of it, 5. And this guy, we can see our ratio is 3. So I'm just going to identify A. That's my first term, which is 5 right there. My ratio we've already identified as 3. And the number of terms, let's just count. 1, 2, 3, 4, 5, 6. This one's kind of easy to figure out the number of terms. Some of them won't be, and I'll show you how to handle those. All right. Then we plug that in. Here we go. I'm just going to plug that in. We're going to say the sum of a series of 6, all right, with a start of 5 and a ratio of 3. It's going to be equal to this. All right. I'm just going to point. All right. Look, my start went here. My ratio went here and here from this formula, and the number went right there. If I keep going, I get this. I get 5 times 1 minus 729 over negative 2, which gives me 5 times 364. That means the sum of this series would be about 1,820. Done. Let's do a few more. And these really aren't too bad. There's a couple tricky ones. I'm going to show you how to handle the tricky one here. Here's one that's a little bit tough to handle because you don't know the number, but let's figure out as much as we can. We got our ratio. Ratio is equal to any term, so let's go 1/8 divided by the term in front of it, 1/4, which really equals 1/8, right? Divided by 1/4, which is the same as 1/8 times 4, and we know our ratio is 1/2. There it is. I'm going to say my ratio equals 1/2. Okay. Our original amount, A, is 1/4. Now the number is kind of tricky, right? So let's find the number. I'll show you how to do that. Your number is found by starting with the original amount, applying your ratio, which we said was 1/4, or 1/2, sorry. And look, if I multiply 1/4 by 1/2 a certain number of times, we're going to call that n minus 1 times, all right, then we should get 1 over 5/12. Again, n minus 1 because we started on the first term. So let's go ahead and do this, all right? Multiply both sides by 4. This times 4, that cancels out. I get 1/2 to the n minus 1 equals, if you multiply that by 4, you get 1 over 128. Now our goal is to get a common base. Well, I know this side is 1/2 to the n minus 1, but I also know that this side is 1/2 because I recognize 128 is kind of a product of 2, power of 2. So 2 to the 7th power, I'll count it out. Look, 2, 4, 8, 16, 32, 64, 128. 2 to the 7th power. So you can set them up with a common base, and that allows you to drop the bases all together. If this is equal, these have to be equal if they share a base. So n minus 1 equals 7. I realize it's kind of tricky, but the number is 8. All right, so I'm going to come over here. And once you've got that, it's as easy as plugging it into the other side. So let's go ahead and write that up here so you can see it every time. Here's the formula we're using. We're saying the sum of a finite series is equal to the starting amount. Try write these without me sometimes so it's in your memory, right? This would be something, if you're going to do a flashcard, this would be something to write in a flashcard so you don't forget it. So here we go. We're going to say the sum of a series of 8 numbers in which the start is 1/4, right? The start is 1/4. And then we'll say 1 minus 1/2 to the 8th over 1 minus 1/2. And there I go. We got 1/4. And this is going to be, well, I'm just going to write this out for you. You can use your calculator for this, but it's 255 over 128 if you've filled that in on your calculator. And the sum of that series is 255 over 512. And that's the sum of that series of 8 terms. We got 2 more to go here. And there is another page I need to find, but we're going to hit these 2, and then we've got a page in which we try a real life situation, or 2. Alright, so here we go. So this one's kind of easy. This one gives us our A. That's kind of nice, right? Our A is 1. That's our starting amount. Our ratio, we can take any term. Let's take this third term. 4 divided by the second term of -2 gives us -2. So our ratio is -2. And the number here is nice. We can count it. 1, 2, 3, 4, 5, 6. This series has 6 numbers in it, or 6 terms in it, right? So this series of 6, all right, is equal to the starting amount over 1 minus my ratio. Put that in parentheses because it's going to matter when you put that 6 power on there, over 1 minus -2, which is going to be, oh, this 1 doesn't do anything in this case. And this turns out to -63 over 3, which is -21. The sum of that series is going to be -21. All right, we got one more right here. We're going to do this and then pause because the next page is a little bit different. All right, it's day 2. And once again, our ratio is not too bad. You can kind of see the ratio, right? To go down to -1/4, it has to be negative, and multiply that by -1/2. You want to do the division, like -1/4 times -1/2 is 1/8. You can kind of just see it, right? My original amount is 1/2. My ratio is -1/2. Let's talk about the number again. So my number here, I can find that out by saying, hey, if I take this original amount, multiply it by my ratio, eventually, n minus 1 times, it's going to turn into -1 over 256. And we're going to just find how many times there are. All right. So if we multiply both sides by 2, I get -1/2 to the n minus 1 is equal to, times 2 gets rid of this, times 2 turns that into -1 over 128. And then I can write this, right? That's -1/2 to the n minus 1 equals, well, -1/2. Let's count that. How many times does this 2 go multiply, or what exponent turns that 2 into 128? Let's count. 2, 4, 8, 16, 32, 64, and 128. So those are the same thing. -1/2 to the 7th power is 128, right? Or 1 over 128. Once our bases are the same, we just go n minus 1 equals 7 and n equals 8. Similar to our last one, all right? Still 8 terms. So we plug this in, all right? The sum of this series of 8 terms is equal to my starting amount times 1 minus my ratio to the 8th power over 1 minus my ratio. And this is important. You got to be super careful because this negative is going to disappear with that 8th power. You're going to get 1/2 over, if you plug this in your calculator, that's going to turn into 255 over 256. And this is going to turn into 3/2, right? 1 minus -1/2. 1 minus -1/2 turns into 3/2. If you work this out, you get 1/2 times 65. And again, this is just plug it in your calculator. And that's going to give you 85 over 256. And there's your answer. I'm going to pause here. We've got just a little bit further to go. And see you tomorrow.